About tests of divisibility, and in this test of divisibility we will talk about the numbers 3, 6 and 9. So remember the rules of number 3, 6 and 9. If you have any number and once you add or sum of all the digits of that number, and if the sum is divisible by 3, so that number is divisible by 3 as well. For example, if we have 2, 1, we can say that 2 plus 1, which is equal 3. So 3 is divisible by 3. That means 21 is divisible by 3. In this way, you can check hundred, thousands, and big numbers as well. The for case of 6, the number is divisible by 6 if that number is divisible by 3 as well as it ends with even numbers, or it is divisible by 2 as well. So for example, if we check any number which is divisible by 6 and 3, we can think about 18. As you can see that if we check 18, sum of 18 is what? Sum of the digits 1 plus 8, that gives us 9, and 9 is divisible by 3, and as well as it ends with even number. 8 is an even number, yes? So that means it is divisible by 2 also. So any number which is divisible by 3 and 2 both, that is divisible by 6 also. I hope so it is clear. And for 9, the case of 9 or number 9 is same as we have discussed about 3. Any number which is the sum of the digits of that number, if it is divisible by 9, so of course that number is divisible by 9 as well. Like 7 plus 2, 9, plus 1, 10, and plus 8. So here we have 4-digit numbers, yes? So if I add all these numbers, that gives me 1 plus 2 plus 7 plus 8. It is equal 2 plus 1, 3, 3 plus 7, 10, 10 plus 8, 18. And remember 18 is divisible by 9, yes? So it means once the sum of the digit is divisible by 9, so that number is divisible by 9 as well. Tick the correct cells to show whether these numbers are divisible by 3, 6 and 9. So if we check the first number, just add all these, okay? Like 2, it's 21,471, okay? If we add all these numbers, 2 plus 1 plus 4 plus 7 plus 1, that gives me 3 plus 4, 7, 7 plus 7, 14 plus 1, 15. So 15 is divisible by 3. It means yes, it is divisible by 3. But remember, 15 is not, or this number 21,471 not ends at any even number like 0, 2, 4, 6, 8. So it means it is not divisible by 6. And the sum of the digit is not divisible by 9. So it is only divisible by 3. Fine. If we check the next one, which is just we add, okay? 4 plus 8 plus 2 plus 2 plus 1 plus 1. It gives me what? 8 plus 4, 12. 12 plus 2, 14. 14 plus 2, 16. 16 plus 1, 17 plus 1, 18. So 18 is divisible by 3. 18 is divisible by 9 as well. It is divisible by 9 and 3, yes, because it not end with the even number. 152,214. So once we add all these numbers like 1 plus 5 plus 2 plus 2 plus 1 plus 4, it gives me 6 plus 2, 8 plus 2, 10. 11 plus 4, 15. So 15 is divisible by 3. So it is divisible by 3. And it ends with 4. So it is divisible by 6 also. So here in question number 6, here is a Venn diagram. Put these numbers on the diagram. So we have 159, 204, 146, 324, 222, 189. These are all 3-digit numbers, but we will follow the same rule of 3, 6 and 9. And the sum of the digit if divisible by 3, so we will write in the column or in the circle of 3. So if we check the first one, 5 plus 1, 6. 6 plus 9, 15. So it means this is divisible by 3. We can write 159 here. And if we check this one, 204, the sum of the digit is 4 plus 2, 6. That means it is divisible by 3 and it ends with even number, okay? 4 is an even number. It means this is divisible by 2 also. So any number which is divisible by 3 as well as divisible by 2, that is divisible by 6 also. So we will write 204 here. And then if we check the next one, 146. So sum of the digit is equal what? 6 plus 1, 7. 7 plus 4, 11. So 11 is not divisible at all on 6, 9 or 3. So we can write 146. Then next one is 324. Of course, it is an even number, but we will check the sum of the digits. 3 plus 2, 5. 5 plus 4, 9. So that 9 is divisible by 3. Yes. 3, 2, 4. Like once you add like 3 plus 2 plus 4, this gives me 9. And remember, 9 is divisible by 3, 9 is divisible by 9, and it ends at 4, so it is divisible by 6. And once you check this one, 222, so if you add 2 plus 2 plus 2, 6, yes? So 6 is divisible by 3, and it ends with 2, so it is divisible by 2. That means it is divisible by 6. So you will write here 222. And lastly, we have 189. So if you add 189 like 1 plus 8 plus 9, that gives us 18. So 18 is divisible by 3, 18 is divisible by 9. So we will write it here 189. I hope so it is clear. Question number 6, it's kind of challenge, but we will see what it is. Koju says multiple of 6 can never end in a 3. Is he right? Give a reason for your answer. Of course, when you think about in your mind the table 6, it is like that, like 6 ones are 6, 6 twos are 12, 6 threes are 18. Everyone knows the table of 6, yes? Did you notice the end point or the unit page, like when it ends, the multiple of 6, it ends with 2, 8, 4, 0, 6, 2, all are even numbers, yes? And he says, uh, cannot never end in a 3, so it means he's correct. Once you read the table of 6 which is a multiple of 6 or any number which is a multiple of 6, it ends with even number, okay? It never ends in 3. 3 is an odd number, so yes, he's right. Even number answer, okay, you can say that even number answer whatever you multiply with 6. So I hope so it is clear. So next question, here are 4 digits, 1, 2, 5, 7. So use these digits to make 3 digits number. So of course we have a place of 3-digit number here down. First we will write the number which is divisible by 3. So if you check differently, you can never find any number which is divisible by 3, 6 or 9. But if you read little bit more, you can use each digit more than once. So then we can find a few numbers which are divisible by 3, 6 or 9. So for example, if we try a number like look, you can think in your mind, but the condition is you can repeat one number, okay? Here in 3 boxes, all numbers must be different. It's up to you. So what I'm thinking it must be the sum of the number must be 9 or 12 or 6. 6 cannot be because we have to bring 0. There is no 0 like 105. So there is no 0. We can use only these digits. So I'm thinking about 171 as we can repeat one number twice, more than one. So if you add these numbers like 1 plus 7 plus 1, that gives you 9. And 9 is divisible by 3, yes. And it is, we can say that it is divisible by 9 as well. But you can write here 171. Maybe your answer is different. It's up to you, okay? Because there are many answers. A number is divisible by 6. That the point is your end must be even number. So it means think about 2 at the end, okay? Like I'm thinking 5. We can repeat 5 two times. 5, 5, 2. So if you check 5, this number ends with 2, so it is an even number. And just we will check it is divisible by 3, yes or no. 5 plus 5, 10 plus 2, 12. It means it is divisible by 3 also. So this number 552 is divisible by 3 and it ends with even number, so it is divisible by 2 also. So that means it is divisible by 6. Fine. So you can write here 5, 5, 2. Maybe your answer is different. You can think about different numbers, okay? And lastly, you can write a number which is divisible by 9. So we can say that 117, like 1 plus 1 plus 7, that gives me 9. And 9 is divisible by 9, which gives us 1. So it is divisible by 3 also, by the way. But we will write here 117. Next question here is a curl diagram with 4 sections A, B, C, and D. Kind of this question we already tried, but here the point is you have to think differently, like write a 5-digit number in each section A, B, D. He is not saying C here. Be focused on point C. And you cannot write a number in section C, explain why, or say 3, 6, and then you can put 0, 0, 0, as we are looking 5-digit number, yes? So this is unit 10, 100,000, 36,000. It's a 5-digit number. If you add 3 plus 6 plus 0 plus 0 plus 0, it gives me 9, and 9 is divisible by 9 and divisible by 3 also. So it means we can write 36,000 here, which is divisible by 3 but not divisible by 9. Okay. So that number you can think again 5-digit numbers. So it must be divisible by 3. Unit 10, 100. Okay. 50,000, 50,000 and 1. So look, if I add 5 plus 1, that gives me 6. Like 5 plus 0 plus 0 plus 0 plus 1. That gives me 6. 6 is divisible by 3 but not divisible by 9. So it means we can write 50,000, 50,001. So that fulfill the condition of divisibility by 3, but it's not divisible by 9. Now we will think about a number which is not divisible by 3 and not divisible by 9. So this can be any number, 50,000. 2. You can write any number here, 5-digit numbers that is not divisible by 9 and not divisible by 3. Now look, if you write all this, here you cannot write any number which is not divisible by 3 and it is divisible by 9 here. For example, I'm saying that I have a number which is divisible by 9, okay, 1 and 8, and then you write 0, 0, 0. You This is 18,000, fine, 5-digit numbers, and 18 plus 8 plus 1, 9. So, of course, this is divisible by 9, but this is divisible by 3 also. Here they are saying not divisible. So, we cannot write any number here. We cannot write, okay? So that's why the reason of you cannot write a number in section C. Why? Because if you write any number in section C that is divisible by 9, it is also divisible by 3. Divisible by 9, it is also divisible by 3. It is. So that's why we cannot write here any number in section C. So you can say like this because. I hope so it is clear.